Yeah, thanks, John, for the introduction, and welcome to the very last talk of today and say of Spark Summit. So thank you all for being here, even though it's the very last talk, and I know some people already left because of the brains, but great that you're here. And if you're waiting for the Fitbit, we're going to do a lottery at the end, of course. So, who am I? That's me, but you can also see me here down there, so it's might be more easy. I'm in the HANA Vora team. Some of you might drop by the booth. I'm located in Waldorf, Germany, which is the headquarters of SAP, even though it's a small town, but nevertheless, we're located here. I do integration into Spark of those SAP engines as a developer in the HANA Vora team for now almost 2 years, so I was kind of part of the people who started the project within SAP to connect those engines there. And I'm very happy that it's already the second time in Spark Summit as a speaker. Last year in Amsterdam was great as well as this year. So that's my experience about Spark, and that's how I fit into the community somehow. So today's talk is basically motivated by two things. So those are results of surveys and studies. So looking at the left one, Forrester Wave study found out that on average between 60 and 73% of all data within an enterprise goes unused for business intelligence and analytics, which means like we're not even using half of the data usually within a company to do actually our decisions, which is not that much, at least from my gut feeling. On the other hand, Gartner says that skill gaps continue to be a major adoption inhibitor for 57% of respondents, while deciding how to get value from Hadoop was cited by 49% of respondents. So there's actually a skill gap, something. People are still struggling to use Hadoop and Spark and all those components in there in order to get value out of it. So this leads to the following actually pretty odd situation. This is what you see at a customer side. So on the left hand, we have the systems they are still using, like I just called them SAP now, but in general, the system that run the companies, where every transaction goes in, what kind of goods you still have in stock, like everything from a CRM or ERP system will be down there. And then most of the companies already started like doing what they call a big data lake or data science and processing and things like that. But they're completely separated, so there's a huge gap in between. So those systems don't know about the others, as well as vice versa. So the problem basically, what Gartner and the others said is like that those systems are not aligned. What we actually need is twofold. From a business application perspective, from things that are already there, they might want to have access to the big data landscape in a kind of a standardized way, and might want to look for same functionality down there in order to move computation from the enterprise side to the big data landscape, because different data might be there, or larger size of data might be there, which could lead to additional insights for your business decision in the end. From the other side, on the big data, the data science perspective, they also want to access the specialized engines to perform analysis on data that they not have on the system itself, but on the ERP system, and might also want to perform specialized analysis, which are not yet available on Spark, say, or on Hadoop, but in the ERP system. Or in a nutshell, we want to integrate the business engines into Spark in order to use it during our Spark jobs. And this is where HANA Vora comes into play. So we put it in the middle of those both sides in order to exactly bridge the gap between the ERP system and your Spark Hadoop world. So from an architectural perspective, it looks as follows. Quick remark: the architecture I show now is is from HANA Vora 1.3, which is still beta. So the version before is already available, generally available, but this is still beta, but it will come pretty soon. Coming back to the architecture, of course, it bridges the gap between the ERP systems and the Spark Hadoop world. That's why it's connected to kind of both. But in addition to that, I'm going to motivate that in a second. We also provide specialized engines for business cases. And they will run on top of Spark and Hadoop in the same cluster, in the same system. And we can interact with Spark with all those engines to use that functionality down there, as well as interacting kind of across the border with the ERP system together. So HANA Vora is kind of in between, doing some processing as well, but also doing the interconnectivity between both worlds. So the goals of developing this were twofold. So first of all, we want to make data and functionality available in enterprise applications as well as in Spark applications. Kind of make it indifferent where actually the processing will happen. It should happen obviously there where the data resides, similar to the Hadoop idea. Just bring the algorithms there where the actual data is. And the second goal we are trying to achieve is to allow easy consumptions. So for instance, allow users to specify their jobs and things we see in SQL for their computation jobs and then decide on the fly where actually do the computation. And this leads me to my agenda, basically deep diving into the motivation I just gave. Well, first of all, talking about business functionality integration in Spark, from a Spark point of view, of course, because, well, we had Spark Submit. And second, how to utilize different data sources, as I just tried to state about the ERP system, the specialized engines in Spark. I'm going to give you a quick glimpse on what engines are in Vora 1.3 as well, which might be of interest, especially looking at the second point of the agenda, the different data sources. And last but not least, I will close with a summary and outlook. So, of course, as I already said, we're going to now put on the Spark classes, kind of. So kind of we are developing and working here. I want to get some information out of it, and this is going to be the focus for the talk. A couple of words to the motivation about why to bring business functionality to Spark. So typical questions answered with your Spark job. You have seen that in the keynotes as well as I guess in different other notes is, for instance, what is the sentiment of users for product XYZ? Or typical predictive maintenance case, when will a certain part of this machinery fail? But you might also want to know, if you got the kind of the first information out of it, what is the sales volume of that product? So if you only sell a couple of things, why should you care about the sentiment, or you should just remove it, whatever it is. Or for a part of the machinery that will fail, you're going to ask yourself, okay, what's still in stock? Or how much did the part cost? Should I just order 10 of them? What should I do? Kind of this is a functionality we can kind of put into while having business functionality on Spark, which we didn't have before. So I'm going to give you a quick example of a different product. This is not HANA Vora, but it's HANA Vora is working on there, but there's something wrong with the font, but nevertheless. Anyways, it's about a predictive analytics tool which works in combination with HANA Vora to exactly use all the data source we have available in the company. Let me give you a quick glimpse on that. If you want to have more information, those are available here, as well as some colleagues of mine are also in the audience working with that. So if you want to have more information, just come to me after the talk. And this URL will, of course, be available in the replay. So coming from top to bottom, so on the very top, we will have some business analysis, want to have some decision out of if something fails and what to do. So this guy on top that uses kind of the most upper layer don't want to have anything to do with any algorithm. He's not a data scientist, just wants to have this thing will fail or this thing won't fail and it will take now 6 months to repair, something like that. He wants to have the actual insight, he wants to have the actual information, doesn't want to deal where the data is, doesn't want to deal with models and things like that. So what do we do? Of course, my colleagues introduce a layer that is now for the data science people, so to say. So what they can do, of course, they will use Spark. Of course, they will use, for instance, Spark streaming, or they will start doing some modeling, depending on whatever they know about the prediction they want to do. And that's on their side. But what they don't care is actually where the data is, right? So it has to be just somewhere. We just want to access it. We just want to have it. But I don't care where it is, as a data scientist at least. So that's why they introduced another layer that includes HANA Vora as well as HANA. And this whole layer abstracts where the data actually resides. So that means you might have some ERP data which is relevant for your prediction, but it's just there and abstracted under this layer to have it available for the data scientists. Of course, we will have the HANA Vora source as well as every other source you can imagine on that Hadoop Spark level, which basically means coming from this layer, they don't care about where it is. And this is exactly where we put HANA Vora in, that we can get ERP data, that we can move computation back and forth, and the colleagues are actually using the technology to get the most out of the data we have available there. And in the end, piling it all up, coming back to the beginning, the business analyst will know what to do, regardless of where the data was. So I'm going to give you an example. So one typical ERP function is converting currency. So for instance, you want to convert euros to British pound or anything else, depending on whatever you want to achieve, like to compare different transactions, for instance. This is actually a pretty simple thing. We implemented a UDF in Spark SQL. It's already known to the ERP customers as well. There it is in UDF as well. So this is actually the easiest way to provide access to currency conversion to users, because they're just going to add it into their query. And of course, it's required to analyze enterprise data if there are currency involved, because usually for comparison, you need to have a single currency. So this is a typical table we deal with. Usually those things are on ERP level, but as an abstraction, as a table, you don't care in the end. But if you want to compare those transactions, if you want to make reason about it, you have to transfer that amount of money to a single currency to make it comparable. And this is, computational-wise, actually a very easy thing to do. You just take the amount, take the date and the currency, and get the rate on how to switch between, I don't know, euro and create the pound or the US dollar. But what's not trivial actually is that the rates might change over time. So you have to know what the rates are at that specific time. Usually you already have it in your ERP system, but to maintain those things is pretty hard, and it should be consistent. So if the scientist A uses, let's say, Spark Hadoop and gets $5,000 out of it, and data scientist B uses ERP data and gets more out of it, even though it's the same data, there's something wrong. So it should be consistent. Coming back to the UDF for a sec, actually it's pretty easy. You just add to the query CC, and then the amount, the source currency, target currency, and the date, of course, and you can add fixed fields as well as columns of your table to finally do the transformation. So what you need then, in addition, is what I already mentioned, is that rate table. You can take the source currency, target currency, the date, actually the rate was determined, and finally you have the rate, and then you do just a multiplication, you're good to go. Calculation is simple, as I said, but the rates need to be maintained somewhere. And usually they are already in the ERP system, so couldn't we use that? Keep that question in mind for a sec while I motivate the second part of it with the time series engine as an example. So let's assume if you speak about the time series engine, it's something we have integrated into the Hadoop world as well. However, this is very specialized to functionality we see in our IoT cases. For instance, we implemented a specific model-based compression thing. So in a nutshell, we approximate the time series function, for instance, via spline or via a single function, depending on whatever complexity you want to have, and we store it in different compression states. And of course, we need to have a multi-representation of those time series, because in the end, you might want to have the original data out of it as well, and not a compressed representation. So this is optimized for the IoT applications. We also have some fast injection path. I'm not going to cover that in that talk. And they store it long time in memory to have it fast available for sources like Spark, and you can use it like there. But using it actually means then having a specific query language. So, for instance, very simple example, standard deviation might also be implemented in Spark, but as soon as it comes to a trend or specific other functions regarding the multiple ways of compression, it gets a bit specific for Spark SQL. So this might not be even able to pass the Spark SQL parser. So the question is here, like, how to use it in Spark. Remember, the currency conversion, we implemented in UDF, but it's not that easy in that case, right? For instance, for the trend, it's not that easy. And of course, we don't want to pollute the Spark SQL parser with very specific functions in for time series, for instance, or for the other engines. So the question is like, how to use that in Spark as well. And that brings me to my second point, how we can finally use different data sources in Spark. For instance, currency conversion, or for instance, the specific time series functions. So, as I said, like, we implemented it in Spark SQL. It's, by the way, also available on our GitHub repository, at least the simple implementation. Of course, you have to maintain the rates table on your own, but the functionality is there. And in order to move the computation, in that case, to the ERP system, because things might already be there and might be easier to compute there. We did something, some extensions to the data source API we call the push down of everything. It was actually the talk last year on Spark Summit as well. I'm going to link it, but give you a glimpse on that. That's the first part. If something is implemented in Spark as well, how to move the computation somewhere else. Second part, as an example from the time series engine, we have a special query language, which might not be covered by the Spark SQL parser, so we do not understand it there, so it's hard to push it somewhere. We still want to use it on Spark, and that's what we call raw SQL. I'm going to cover that in the second part of the functionality we have on Spark level. So first of all, a quick glimpse on the push down of everything. So if you're familiar with the data source API, actually it's a very cool and great way of extending Spark to different data sources. So you might already have some files on HDFS and work with that. That's fine. You're going to get them over the core engine or via SQL in. But if you want to have access to different systems, meaning SAP products or as well as MySQL or other databases or even JSON files, you usually use a data source API. It's a very convenient thing. Just add it, read the data, you're good to go. However, of course, you want to use the computational power of those links. For JSON file, it's pretty limited, of course, but for MySQL or other databases, like HANA, for instance, you can push down a lot of computation there, or let's say a lot of part of the algorithm there, in order to finally use the computational power you have there, instead of transferring data back and forth. So that's the reason why in the standard Spark data source API you are able to push filters and projects to the source, just implement in simple interfaces. But as I said, like databases might be capable of doing even more than filters and projects. So what we extended is the so-called Catalyst Source API, and it finally it summarizes in kind of the following very easy intuition that the data source itself, like the implementation there, can indicate its processing capabilities. So you form a logical plan out of your Spark SQL command, and then in the end, the data source says, okay, I'm able to produce this, and this, but not the remaining part, and then the remaining part is pushed to Spark. So with that one, we are able to process arbitrary parts of a logical plan, including the UDFs, because data source can say, I do understand it, so I can compute it, and we can then finally compute where the data actually is, including UDFs, including every functionality we have on Spark SQL level available as logical plan elements. If you're interested in details, there's a talk available as well as the interfaces on our public GitHub repository. It's called the push down of everything. Feel free to watch it or feel free to ask me anything about that as well. As an example, consider this query. So it has the order date as well as the average of the amount of money spent in US dollar. If you would only have the chance of pushing down filters and projects, this will, in that case, will lead to a simple scan on that table, because we cannot process the average, we cannot process the currency conversion if we would use standard API. But if we can push down arbitrary parts, if as a data source can signal, okay, I'm happy to do it, we could push down basically anything, which in the end will lead from data source to Spark. We will only return one row per order date, but on the other hand, we will return the whole scan of the table. And of course, we will also have the converted currency available, which then means we only need to maintain the rates table on the one side of the system, in that case, in the ERP case, or whatever database you're referring to. So again, this is the case where we can pass the query, we know what to do, but what about queries we are not we are not aware of the syntax? And that's what we call raw SQL. I'm going to explain it to you in a couple of words here. What we did is basically we kind of adapted the data source syntax in order to pass arbitrary queries to a data source. So you'd use those backticks and say something query, backticks end, and then say using Comstar Spark engines. If you implement the appropriate interfaces, we provide then this whole literal in the end gets passed to the data source. So in a nutshell, what will happen is that Spark parses that as an arbitrary string and says, okay, this has to be something with a raw SQL execution, because using and that arbitrary string finally fits it up to pushing down that one down to the data source. And during logical planning, we of course need a schema for it. We cannot infer it from here because we don't know about whatever is in there. So we get the schema for that query, for that specific one, from the appropriate engine, in that case a time series one. In that case we return two columns, pretty easy one. And then during physical planning we execute the query kind of again, but then for getting the data back. So this means it's seamlessly integrated into the existing catalysts and logical and physical planning here. But you can write arbitrary queries here. Doesn't even have to be SQL as long as your data source understands it. So summing those both things up, having both extensions allows us to incorporate other data sources extensively, even though if it has a different query syntax. The computation, that's very important, of course, happens where the data is. We try to move as less data as possible. And the integration is mostly seamless for a Spark developer or for a Spark application. I say specifically mostly because, of course, using raw SQL with those backticks is not like what you already have in Spark. You might have to change little things, but it's mostly seamless in the sense that in the end we use standard data source API with some extensions. Those interfaces and some basic implementations are available open source. Just go to that one. You're going to find them for raw SQL as well as for the Catalyst source API. For specific source, of course, we didn't implement everything there in the open source part. But of course, that's a very good starting point in order if you want to use it in the end. So coming back to the functionality of HANA Vora, just to give you a glimpse whatever engines we provide there, is first of all, you also have a relation engine which was already released. That's also distributed within the cluster and does some query compilation based on an LLVM interface in the end, and of course has columnar data layout as every modern database nowadays has. We also provide a disk-based engine if you don't want to have everything in memory in order to process even larger amounts of data. You can basically choose which one to use. In addition to that, those engines also support business functionality like hierarchy processing. We already announced that a couple of months, 1 year ago as well. And we are also looking for extending the functionality to currency conversion, all those things that you can perform, similar things you will do in HANA on the Hadoop cluster as well. So coming to the other queries, I already talked about time series, of course, is, for instance, for the graph engine, we followed a similar approach as the time series one. We store the graph in a special partitioned way in the cluster memory and then make it accessible to Spark, that we can have it long running there and every other Spark job can use it there. So it's comparable, SQL-like interface also that's easy to access, which is kind of comparable to other graph engines you might know, but this is a similar thing. Nevertheless, specialized in memory representation, try to partition it according to the data to get it very fastly done with the in-memory graph engine. Similar arguments for a doc store, so it stores JSON and compresses it, of course, and the compiled queries are even NUMA aware on a single node level, and it can be accessed via Spark, as I said already, with the raw SQL interface. So summing it all up, I hope I was able to show you that with Vora, with HANA Vora, we are able to combine different data sources in enterprise environment across different query languages while moving the computation close to the data and while make it easily available via SQL to users that are not experienced in writing complex programs there but just want to use SQL in the end. The business insights in that sense can be driven by all the available data in the enterprise and not only just a subset, as we have seen in the beginning in the studies, that only kind of 60% are unused, which means if we can access different or all the data sources, we might be able to use more data for our insights. And again, integration to SQL makes it actually very easy and easily consumable for all the users, including the automatic optimization that we already do know from Spark SQL. So thank you very much for your attention. I'm happy to take any questions, of course, and in the end we're going to do a little raffle. Thank you. So are there any questions?
Yes, it works.
Yeah.
Does this make sense for a business that does not already use SAP as part of their stack?
Good question. Yes and no. I mean, it depends on whatever the business you're talking about stores its data. So, for instance, I went beginning of the year to a conference in Munich where I listened to HelloFresh. I guess that's fine to say, and they built the whole enterprise ERP system on top of Hadoop. So, in that sense, it would not make sense because they already have the data already there. If you want to do that, then that's the better solution. Just take whatever you have in Hadoop available. But if you have any other system that actually takes a lot of your company data and say what need to be accessible via Spark, it would make sense to use Vora as well. Of course, we provide interfaces for SAP HANA, for SAP HANA Vora, but not for any, let's say, data source currently. Of course, the interface will stay the same. If you implement it on your own, you're good to go with that as well. The specialized engines I talked about are available standalone and make sense without HANA as well. But of course, depends very much on the use case. So, for instance, if you want to go for an IoT one, coming back to the time series engine and want to have that special functionality of different compression, for instance, then it's a standalone product. So, yes and no. Yes, the interfaces and the products make sense depending on if you don't have your data on the cluster or if you want to do specific processing. Thank you. Any other question? All right. So, thanks a lot.
Let's give a big thank you for Stephan.
And for those of you who actually signed up for the raffle, just gonna do. Hope I can read the name and the people is already there. So, Van Impe Philipp. Okay, next one. Oh. Rublis Sutuk? Why do you participate if you're not there? Okay, next one. Vincent WYLN. Not there as well. I didn't thought it would be that complicated. Do you want to have it, Sean? want to give it a try? Yeah. So this is Walter Ferrara. Guys. Okay, I try it a second time. Bernhard Schlegel. If someone says he's Bernhard, I guess I would believe him. Christiane Stein. Looks like a girl. She's from Cloudera. Oh. Pavel Piniacek. How is that possible? Next time we need something else. Some other. Do you want to give it a try? Maybe you're lucky, more lucky than I am. Burok Isnir. Ah, finally. All right. There you go. But you have to signature that your name and stuff, and your signature that we are kind of. If it kills you, we don't care. That's kind of the story.
So let me take 2 seconds, everybody.